Hey, welcome to Engineers Workshop. Been real busy lately doing a lot of work on the K&T, finishing up some old projects, starting some new projects. I wanted to show you a little bit of work I did recently that involved, I guess you call it mill turning. So when you chuck a piece up in the quill and put a stationary tool in the vise and then use the mill as a lathe. There's a good number of YouTube videos on this, but I figured I'd give it a try and needed to for some of the things I had to make to move forward. So let me show you that, but before we do, I want to get you caught up on just a couple updates and issues that I had. So real quick detour, I'll show you a couple things here and then we'll get over to the K&T. Had the spindle switch go out on me the other day. It failed mechanically. It won't actually snap left or right. And I thought, well, great, I have a spare. I knew it came with a spare, but unfortunately it was a spare failed one. Even though this one appears to snap in one direction, I can't even get it to snap back. It does not switch electrically. I looked up the numbers. This is a Carlton, and the big numbers on here, the 80638, if you put that in, that is the 3/4-32 lock nut. So the actual switch number is a Carlton 8947. It's a double pole, double throw, but the circuit only uses a single pole, double throw, uses half of it. But I can't find one of these. If anybody knows where I could find one or has one, I do want to get that replaced. In the meantime, what I did was I tapped into the circuits and I used this is a NEMA, I think they're Allen Bradley 35 millimeter switches, industrial controls, and I wired it in so that I have control of the spindle with this little pendant, and I'm going to mount the pendant basically on my arm that holds my DRO. Like an idiot, I had this thing sitting on the ways, which is a horrible habit to be in, and you can see I haven't broken it yet, but I was making a cut and I was running my X-Travel across, and this thing got pinched between the table and the end here until it jammed, and I stopped it, but I couldn't use the hand wheel to release it. So this thing developed enough force to kind of crush the NEMA 12 box. If it had gone much farther, I don't know, maybe it would have broken this off the end of the table, but I was able to power feed it back in the other direction. But I'm going to mount this guy right there in the meantime until I get another switch, because it's just basically so convenient to have it right up here at the head. Wanted to introduce you to a new tenant at the shop here. This is a 1964 Ford F800 flatbed truck with a liftgate. This belongs to my buddy Heath, same gentleman who owns the Acroturn 1340 lathe. And Heath had an opportunity from a gentleman who has a lot of vehicles similar to this to get this, pick this up pretty cheaply. So he asked if he could store it over here for an undetermined amount of time. I said, yeah, no problem. His long-term plans for this truck, I believe, are to put a modern powertrain in it, like Cummins turbo diesel, and then do something with the axles and brakes, because this thing has air brakes and a type of wheel or rim that is not readily available, and like brake drums and brake components are not available for it. So he might be looking into military axles for it or something like that. And because of the engine swap, it means that the powertrain, the original powertrain for this, he does not want. So we believe it has a 390, 392 barrel, and that engine is available to me if I want it to put into the F350. So at least I have a reciprocating assembly for a 390 to put into the F350, which has a 360. Note the air horns on top of the cab because the truck has air brakes. And this is the current 390 engine, which unfortunately appears to be stuck pretty badly. But we're going to pull it out and do an assessment of it. My father-in-law had given me literally a bucket full of tooling that he had from when he was working at the mill. And there was a lot of basically hand ground stuff, really impressive cutters. Here's some high-speed ones. We got a number that have brazed carbide. I ended up using this in my initial trials in the vise because I could face with it traveling the table, or if I passed the quill down over it, I could turn the diameters down. Got some with more positive rakes. A lot of these, I didn't want to mess with because really I don't have any way of regrinding these, especially with all these, nice chip breakers ground into them. He did have one tool that held the diamond-shaped inserts. Might have a good edge on it in there somewhere, but a lot of it's chunked out. And this was the piece of stock that I had gotten from McMaster to work with. But anyway, just playing with these a little bit, got me thinking I better get something with a little bit more beef to it, and wanted to get a CNMB, I think it's a CNMB insert, about a 1/2 inch, not quite the biggest one, but got this Sandvik left hand, it's a 1-inch shank tool, just off eBay, real cheap because of the opposite hand. But when you're mill turning and you got your quill conventionally spinning in this direction, this is what you want, and this will both face and reduce the diameter. So most of what you're about to see, I was using this tool, nice and rigid. It can stand up in the vise and not introduce chatter for the relatively mild cuts that I'm taking. But let's head over to the mill and show you what the results were like. Another couple interesting items that he had that was in a little tub full of all these taper pin reamers were these little carbide brazed insert cutters. I have about 3 of them. Now they have quite a number of little cutting edges, and the rake on these is such that these things actually operate opposite hand. They're rotating this way. And they're all scribed with L, I assume for left hand, 20 degrees, so they're a 20-degree angle to the surface. And they have a 5/8 arbor with a set screw. Actually, I checked this with the parallels, and that's 0.626. So I had no way of holding these, and what I wanted to do was make an arbor to hold this because I have a use for this on the K&T collet nuts. I'll show you a quick shot of machining those, although I'm doing an entire video series on making those. But wanted to make an arbor to hold these cutters, and then they would go into the collet of the K&T. So that's what you'll be seeing in this video that I'm doing the mill turning on. The stock I chose from McMaster was a 4140 medium hard 1.1/8 round. Man, was it tough to cut. You could see the discoloration I had there using just a cutoff disc. Got to get my power hacksaw back up and running. But when I chucked it up, man, did it turn nice. The chips were just beautiful, as you'll see in some upcoming shots here. I have to remove material up to 900 thousandths, so I'm going to use the feed. I'm going to dial in a very slight cut. Let's go until we touch. Dial in 5. And feed down. Now I'm feeding the table the wrong way. Try a 10 thousandths cut. This is 20 thousandths depth of cut. I think it likes that. Who needs a lathe? I'm going to try a 30 thousandths cut. It's cutting so well. It's just singing through it like it's not even there. Let's do one more like that. The cutter, even though it has a set screw, I just want to do a light press on the arbor. It currently has a bore of 0.626, so I'm going to shoot for an arbor diameter with a thousandths press of 0.627. And I just checked progress on the arbor there, and I'm currently at 814. That gives us a difference of 187 thousandths. 3 30 thousandths cuts will bring us down to 634, which leaves us, 7 thousandths or so cleanup. I think that's good enough to get that close, and then we'll hone in on the 0.627. So we'll dial in another 30. Make sure I'm going in the right direction. 3 passes at 30 thousandths. Last pass. Well, let's see if we're at 634. Classic rookie mistake. Each pass gives me twice the diameter reduction that I calculated, so I'm undersized. So we get to make a new blank and start this all over again. Well, now that you're done laughing at me, let's do this again with a piece of 1-inch stock. It's got a little bit of paint on, but I'll be more careful of my math and take this down to 627 from 1 inch. I think that fully cleaned up. 30 thousandths. 942 and a half. I should be able to do 4 more 30 thousandths passes. The second piece of stock that I selected was a piece of 1-inch round that was, for the most part, painted. And I've got to check this, but it almost makes me wonder if it was mild stainless because of just the way it acted. The chips wouldn't break, and it was producing a lot of, relatively long shavings that did eventually curl up and break. But towards the end there, as I got the diameter turned down, it started to produce a continuous curl. Must have been 20 feet long. I mean, it just snaked over and laid itself down behind the table nicely and just kept feeding itself out like a spiral across the floor. It was kind of neat, but I thought, well, boy, if this thing snags and yanks the camera or my hands into it, that wouldn't be good at all. So finished up the rest of the turning without incident, but the material just definitely didn't respond as nicely as the 4140. This material is definitely not breaking chips like the other one. We're 16 thousandths away. So let's take a 5 thousandths cut. .632. 5 thousandths away. Now a 2 thousandths cut. I'm at 628 and a half. I'm gonna have to get creative to dial in that last cut. I need 7/10. I've got a digital readout that only reads in half thousandths, so I'm going to dial in a half thousandths on the DRO and see if that corresponds with a half thousandths there. That's a half. That's about 7/10. So let's go with that and hope we didn't overshoot it. I'm going to feed the table back and face that shoulder off. As I was watching it cut, that tenths indicator drifted up to 8/10. I did not touch that dial. 6270. Make a little bit of a lead in. So it just starts to go, then it gets tight. So we'll heat this guy up and see if we can drop it right on there. Shouldn't take much to get this to go on. So we will heat this up a bit, and I've got a mallet to help persuade it if it does get stuck halfway. Approaching 300. Now let's try 300. Good enough. Let that cool. It's already gripped it. Well, I hope you enjoyed that little mill turning exercise. The K&T works really well as a lathe. I mean, it just seems rock solid, and as long as you're working with something 1 1/8 diameter and no longer than about 3 inches, it makes the best 5,000-pound 3-inch mini lathe that I've ever seen. So I'm going to continue to add that little trick to my arsenal for moving forward. Whenever I need to make parts, hey, put a tool in the vise and do some mill turning. So anyway, thanks again for watching. Thank you for all the new subscribers. Hitting that subscribe button and the bell icon will keep you updated on what's going on here at the shop. So try to get another one out for you next weekend. And until then, as always, stay safe.